Okay, this video explains how I monitor the Apache NuttX project every day to make sure that everything is okay. I've been doing this every day for the past year. Um, if anybody wishes to take over the monitoring, please let me know. Or maybe somebody has some idea how to fully automate this. Right. The first thing we do in the morning, it's 7:30 Singapore right now, is to check our utilization of GitHub Runners. So this is a live stats. We need to keep the full-time GitHub Runners under 25. So 5 is a good number. We created our own stats that measure the number of GitHub Runners over the past 24 hours. Why do we do this? Well, the default stats given by the ASF infra team are kind of a bit too non-granular. So that's why we decided to write our own script to create our own metrics here. And what happens if we exceed 25? Well, bad news. The infra team might actually cancel our access to GitHub CI. So it's very important to keep this number below 25, and that's why I monitor this every day. Now, what happens if this number exceeds 25? How do we find out what's wrong? Well, we'll need to check the logs. That's why we have a list of all the build actions here. Make sure that all the build timings are reasonable. So we expect the longest builds to complete in 3 hours, but there should be shorter builds like this, for example, that complete under 3 hours. It depends on the complexity of the PR. Some PRs are quicker and easier to test, to check, so they should complete earlier. So for example, this PR is for ARM32. It completes under 3 hours. In fact, it's about 2 hours, right? And there are even shorter ones, right? But in general, we're looking for jobs that run way more than 3 hours. Something is seriously wrong if this is beyond 3 hours. So this is one repo that we're looking at, the NuttX repo. The other one is the NuttX apps. We also need to make sure that everything completes around 3 hours, right? So, for example, some of them might be getting a bit slow, 3 hours, 30 minutes, right? But in general, every NuttX build for NuttX apps will take 3 hours, slightly over 3 hours. That's because we don't have any simple PRs in NuttX apps. Every PR in NuttX apps is a complex PR, which will do the entire build. So that will take about 3 hours plus. Right. Now, we made some changes to our CI system because we had lots of problems managing the load. We had to make drastic changes to let it run below 25 GitHub runners. That's why we offloaded our builds into a mirror repo. Okay, this is the NuttX mirror repo. So our builds are running here. We have a script that will watch out for builds here whenever there are new PRs being merged, and whenever this build completes in 3 hours, we have a script that will fire off a new build. Now, so the problem is this. We offload our builds into this mirror repo, which is not counted under ASF accounting. But problem is that now we need to monitor the builds here, make sure that nothing fails. That's why we built a NuttX dashboard. This dashboard looks at the builds from 2 places, from the NuttX mirror repo, as well as our NuttX build farm, right? So we have the NuttX repo, mirror repo here that's running builds every 3 hours, assuming there are PRs to be merged. But within those 3 hours, things get merged, and we won't know what is the impact of those things that get merged. Also, any changes, any PRs that merge to NuttX apps will not trigger a build on the NuttX mirror repo. So that's why we have our own NuttX build farm. for doing the builds continuously. We're running about 4 builds per hour concurrently, so that way we can catch problems earlier, right? And so if somebody merges a NuttX apps PR, it will probably be caught earlier by our NuttX build farm instead of our mirror repo. Now, so we see this dashboard here. In the morning, we have a lot of reds. We can see the difference in the URLs. So we have URLs that go into GitLab, NuttX build log. We have also build logs that go into github.com/NuttX. So these are more important. These are coming from our mirror repo build, right? So something is wrong with our mirror repo build. We should seriously look into this. The rest are coming from our NuttX build farm, which is running on my workstation nearby. So not so critical, but eventually we need to look into them. But if you look at the message, you can see that this is a common problem. We always see things like, end of central directory signature not found, RPC failed, and all that. And notice that it's usually ESP32. What's happening here is that the build, either from the NuttX build repo or from the NuttX build farm, tries to download the ESP32, dev kit, the ESP32 runtime libraries from GitHub. But for some reason, the download fails, even though it's running from GitHub. Right? And we see these errors. And this is something that happens a lot to ESP32 builds. So, when I see these kind of errors, signature not found, curl not found, whatever, and it's coming from an ESP32 build, I tend to ignore these, right? And if everything's running okay, we won't see the reds. Okay, we will see more greens on it. Right. So this is a helpful tool to figure out, what our builds are like, what could be wrong with our builds in NuttX mirror repo, and also in our NuttX build farm. Right. Moving on, we have here. Okay. Our NuttX dashboard is running on Google Cloud, so I need to make sure that our costs are running okay. So right now I'm paying for our hosting at Google Cloud VM. NuttX dashboard is costing us about 52 Singapore dollars a month to run. I have to make sure that we don't overuse too much of this. So remember this, I said that there was a script that will automatically check every 3 hours and trigger off a build at the NuttX mirror repo. This script is also running on our Google Cloud VM server, the same server that hosts our NuttX dashboard. Right. Now, at about 8 a.m., we will see some build logs appearing in my Gmail. We'll come back to that in a while. So normally I need to check that all the builds are okay at 8 a.m. also. Moving on, we have our monitoring of our bandwidth usage. Remember that we have a Git server, a Git repository running on Forgeo. It's called nuttxforge.org. So it's running on my machine. I need to make sure that everything is okay. We don't make sure that we don't consume too much bandwidth. So if you haven't seen NuttX Forgeo, let's go into NuttX Forge. We have 2 interesting repos here. Firstly is the NuttX mirror. So this is a read-only mirror. It will automatically sync from the NuttX repo to keep everything in sync. So it comes from here. So normally I'll just check that the hash is the same, 121E, which matches this 121E. This sync is done automatically by Forgeo. It will pull down the files, and put it into this repo. So this is a good place for people who want to access NuttX source code without accessing GitHub. Now, this is a read-only mirror. This means that you cannot create, PRs and all that. That's why I created a second repo called the NuttX update. So NuttX update will have things like pull requests and so on. And you see that the hash is also the same as you saw earlier. So that's because I run a script that will sync the updates manually. Using our own script from NuttX mirror to NuttX update. So this is a update version of the NuttX repo. In case anybody wishes to submit pull requests, well, we have one way of doing it here. Right, so that's our NuttX Forge repo on Forgeo, and I'm making sure that this thing doesn't exceed too much bandwidth utilization every day. Right, moving on. Let's talk about the background processes running here. So we have two Docker containers. So we have the Forgeo Git server, which is running in Docker Compose here. Now, we also have a Mastodon server running here. So why are we doing Mastodon? That's because, remember earlier we said that we have a NuttX dashboard that monitors the jobs, this one here. Well, if something goes wrong, we want to be notified, and we do it through our Mastodon server. So this is quite useful. I just need to install a Mastodon client on my phone, and I'll get a push notification whenever something goes wrong, right? So the Mastodon server is for monitoring our NuttX builds. But who actually pushes the messages to Mastodon is that we have this script here, NuttX Prometheus to Mastodon. So we actually, this is the guy that actually monitors the builds, looks for any kind of failed builds, and pushes it to Mastodon. So if I were to reset this and run it again, okay. So we can see that this guy is actually pushing up the notifications to Mastodon, and I will get a push notification on my phone. Okay, one last thing here on the right side. This is our NuttX build farm. We have a Ubuntu workstation with Intel Xeon, super powerful. We are running 4 concurrent jobs on that workstation. So you can see right now it's running ARM2, ARM13, RISC-V 3, extensor 2. Right? So we were roughly getting a throughput of 4 jobs concurrently within 1 hour. So this will cycle through all the jobs, making sure that all the builds are okay. Why are we doing this? Well, because our NuttX mirror repo only builds things every 3 hours. Within those 3 hours, we may get PRs merged, and they will not be picked up by the build yet until the next 3 hours. That's why we run our own NuttX build farm to build everything, including the latest PRs. Also, remember that our NuttX apps will not trigger a build on our NuttX mirror repo. That's also why we're using the NuttX build farm to actually pick up any changes from the NuttX apps and compile it continuously 24/7. So all this is running on the latest version of NuttX repo with the latest merged PRs, as well as the latest NuttX apps repo containing all the PRs merged as of this point in time. Okay, the time is almost 8 a.m., but let me show you what I monitor normally after 8 a.m., let's say 8:30. At around 8:30 every day, I will receive test reports, right? These are the build test reports for all 64, actually 2000, Star Pro 64, and Avatar A1. Right? So this happens every day. I'll see the renew reports every day at 3:30. So looking at yesterday's reports for now. What I'll do is to make sure that the daily test and build is successful for these platforms. So we can see that it's doing a build. It's downloading the latest code from NuttX. Then after that, it's actually connecting to the SBC, right? Booting up NuttX on this device. After that, it will run OS tests. So it will complete all the way. So it's all automatically scripted. I need to make sure that I scroll all the way to the end and look for test OK. Exiting with status 0. Right? That is for all 64. I will go into Star Pro 64, which is quite the same. It's also building for RISC-V. Then after that, it will boot NuttX over TFTP, right? You can see here. And finally, we have a script that will run OS tests, like here, right? So OS tests will keep running. I have to make sure that it says the test is successful. That's okay, exiting with status 0. Right? And one final check I do for today is Avatar A1. Avatar A1 is different. It's running on ARM. So we actually use an SD card multiplexer, which is a bit more complicated. We built the ARM64 version. We actually copy it into a multiplexer, SD wire. And then after that, we boot Avatar A1 to run the test. And by the way, we are using the IKEA smart power plug to turn on our SBCs and turn them off. So we can see that our Avatar A1 is booting NuttX now. We do the same old test, and eventually we run OS tests. I will scroll all the way to the end and make sure the test is okay. That's okay. Exiting status 0. Yeah, that's it. Every day, 8 a.m., 8:30 a.m., I'll make sure that all these three tests are okay. So this will make sure that our NuttX is really working okay, compiles okay, and works perfectly on 3 SBCs, R64, Star Pro 64, as well as Avatar A1. So we have the confidence that things are actually going okay on real hardware, and this happens every day. What happens if something goes wrong? Well, I have to backtrack and look at the PRs that merge, and then raise this issue with the PR that's causing it to break. Okay, in a while we'll see more tests coming in. So we run a couple of tests in GitHub Actions to do tests on other platforms like QEMU, RISC-V, and so on. This will happen at around 8:30, 9 or 10, right? So second part of this video, we'll come back and look at these builds from GitHub Actions. Okay, let's continue. The time is now 8:30 a.m. in Singapore. We have the build and tests of NuttX that's being done at GitHub Actions, and we have the results here. Now, why are we doing this? Remember earlier we talked about the the build and test logs for real hardware. This is running on R64, Star Pro 64, Avatar A1, and this is running on real hardware. We actually downloading the latest source code, building it, and we are copying it into the SBC using a SD card multiplexer. And we actually do boot the SBC and we run OS tests to make sure everything's okay. Right? Now, obviously, it's best to run this on real hardware, but sometimes it's just impossible to do this on real hardware for all the SBCs that we have in NuttX. That's why some of our testing has to be done at GitHub Actions with emulators. So every morning at 8:30, we'll see a whole list of test results. So we'll see things like NSH, right? NSH is quite easy to test at GitHub because we can actually run the QEMU emulator on GitHub Actions. So for example, if you look at this NSH here, we can see that the build is happening at GitHub Actions. We install QEMU and we run a test. Everything actually happens here on GitHub Actions. We boot the QEMU emulator. We run the OS test, and we monitor the result to make sure that OS test is successful. Right at the end here. What happens if this test fails? Well, this build will fail, right? And we'll get a result back in our in our email that this build and test has failed. So NSH and KNSH is quite easy to simulate in GitHub because they are supported on GitHub. Okay, some other things are a bit more complicated. So we look at, let's say, Aux64. Okay, Aux64 is a bit more complicated because it doesn't have a QEMU emulator. However, we built our own emulator based on TinyEmu. If you look at the GitHub action steps here, we can see that we're actually doing the build, right? Okay, this is the build part. Let's move on to the daily test. Okay, for daily test, we use our own emulator. So we're actually building our own BL808 emulator that we customize from TinyEmu, right? And after we build the emulator, we run a test. So it's a bit similar to what we saw earlier for NSH and KNSH running on QEMU, but we are now using a TinyEmu emulator. But the steps are the same. We are running, the same commands in NuttX. We are also doing OS tests, and our script will check that it runs okay at the end here. Right. We are using an expect script to make sure that everything works correctly. And if this test fails, we will see an error reported in our email. So pretty straightforward. Now, things are a bit more complicated for some other builds. Okay, we don't have emulator yet for Star64, right? And we don't have emulator yet for PinePhone. So these will only build. They won't actually do any tests. Now, SG2000 is a special case, okay? Let me show you the build from yesterday, right? SG2000 is essentially the same as the OS64, SG2000 SBC. What we do is that we run an auto test script, okay, on my machine here, which will download the NuttX firmware that was built by GitHub Actions. It will copy it over to the our TFTP server, and then we'll boot our NuttX image over TFTP, and we run an expect script, to make sure that all the basic NuttX commands are okay, including OS test, and we make sure that the result is okay, right? So it's actually quite similar to the SG2000 that we saw earlier here. All right, that's for SG2000. So it's a bit different from the others because we are running on real hardware instead of emulator. Now, then we have a bit more problematic ones. We have the NSH64 and KNSH64. The problem that we have with 64-bit RISC-V QEMU is that it doesn't run correctly with OS tests on GitHub Actions. So what will happen is that these scripts will do a build of the NSH64 image or KNSH64, and then after that we have a script running locally on my machine to pick up the build and execute the QEMU test for NSH64 and KNSH64. and then upload the results back into GitHub Actions. Back into the GitHub release. So we click into the GitHub release here. We'll see that here's the log. So it will download the latest build. It will run QEMU for RISC-V 64-bit. It will run an expect script with OS test and make sure that the OS test completes successfully. And it's truncated because NuttX release notes are not able to take in the whole thing. Okay, but the sketch. Okay, so you see here that we are actually running 20 attempts. Attempt 1, okay. Attempt 2, okay. Attempt 3, okay. This happens 20 times on my machine. Why are we doing this? A year ago, we detected some intermittent problems with NuttX on RISC-V 64. So that's why we are doing the test 20 times. And we have to make sure that all 20 times are successful. Because there have been cases where, out of 20 times, maybe 10 times will fail or 1 time will fail. To prevent this kind of intermittent bugs, we run it 20 times just to make sure that all 20 times are okay. Right? Make sure all 20 times OS test complete successfully. We do this for NS64, and we also do this for KNS64, this guy here. So we'll see here that, yes, it runs 20 attempts, all right? And these are our 20 attempts here, which will be truncated because not all 20 logs will fit into the GitHub release notes. So you can see here that OS test returns okay, 1 attempt successful, and then we begin the second attempt. So this goes on for 20 iterations for all 20 attempts. And we see on top here that attempt 1 okay, attempt 2 okay, and up to 10, 20 okay. So we need to make sure that all 20 attempts are okay because we have seen problems in the past where NuttX on QEMU RISC-V 64 will fail because will fail intermittently because of some issues. And this is what we do every day to make sure that our monitoring of NuttX is happening. Everything's okay, and it runs on real hardware as well as on emulators. Earlier on, we talked about our Mastodon server that pushes out notifications from a NuttX dashboard. This is what it looks like, right? Remember that we have a NuttX dashboard like this that will monitor the builds happening at the NuttX mirror repo as well as our NuttX build farm. Any errors that detected here will be caught by our script, our NuttX Prometheus to Mastodon, and then it just will push up into our Mastodon server here, running under the Docker Compose. And on my phone, I have a Mastodon client installed, and I will see the errors. Right? Okay, so as I said again, ESP32 is particularly prone to failure. We're not sure why. We try to download the ESP32 runtime from GitHub, and somehow it fails. Right? That's why we see these errors. And it's not just our NuttX build farm that's having these failures. We also see the same thing happening on NuttX mirror repo, which is very strange because NuttX mirror repo is building NuttX within GitHub, and it's downloading the ESP32 runtime from within GitHub, and yet it fails. So this is a bit weird, and it only happens to ESP32. Doesn't really happen to other things. So anybody knows how to fix this, please let us know. It's very, very frustrating. Every morning waking up and you see a lot, whole screen of red. Okay, and that's it. That's what we do every day to monitor GitHub. To monitor that NuttX is running okay on our for everything. We have a live metric for GitHub Runners to make sure that we're not using too much GitHub Runners. Otherwise, ESF infra team will shut us down. So we need to make sure that our full-time GitHub Runners is below 25. Anything goes wrong, we will look up the build logs to make sure that everything completes around 3 hours plus. If something goes beyond 3 hours plus, like 4 hours or 5 hours, something is seriously wrong. Same thing for NuttX apps. And because we offloaded some of the builds into the NuttX mirror repo, we created our own NuttX dashboard to monitor the builds. This NuttX dashboard monitors builds from the NuttX mirror repo, as well as our own NuttX build farm. Why are we running our own NuttX build farm? Well, that's because the NuttX mirror repo can only build every 3 hours. And any changes to NuttX apps will not trigger a build at NuttX mirror repo. So that's why we are doing our own builds on NuttX build farm. We are building roughly 4 jobs concurrently in 1 hour. Right? Any errors detected in the NuttX build farm or in the NuttX mirror repo will be reported to the NuttX dashboard. This will be picked up by our NuttX Prometheus to Mastodon script, which will push the errors to our Mastodon server, and our Mastodon server will push out notifications to our Mastodon client, to tell us that something failed. Yep, and this is how everything works, and this is what we do for monitoring our NuttX status every day for the past year or so.